Hello, 8th graders. We're looking at last week's packet and not even getting into the book today, and then we'll start on the new packet. I can't believe, I think I gave you the new packet already last week, so that's what we're looking at. You can watch, though, to see how we deal with last week's linear situations. Rats, I don't have a pen. Okay, light company. A lot of these you need calculators for. The calculators are behind Martine and Wyatt.
Little piece.
Oh, rats, I see. I have a pass for Billy, but he's not in my Okay, good. Bye. All right, my friends. First page of the packet. I want to look at this situation before we look deeper at the other pages. While these linear situations are real life, they may or may not be your real life. For example, this one's about a light company and what they charge for the PG&E bill. How many of you pay your PG&E bill? Okay, so again, real life situation for myself and Mr. Craig, maybe, but it will be a real life situation for you in the future. But there's probably some things in here, actually, that would probably confuse even Mr. Marwood, because I pay the bills. And a lot of people who pay their bills just look at what they owe and hand it on over. But if you wanted to read it and understand it, one thing to understand is how they charge you for electricity. So here we have EW Light Company. Somebody to read the little situation about EW Light Company. Thank you, Jerry.
The E&W Light Company charges their customers 14 cents per kilowatt hour used. The E&W Company sends their customers their bills monthly.
Okay, so box the thing that says 0.14 kilowatts per kilowatt hour used. So confusing in this is that 14 cents a little bit because they write it like a dollar. So it's fractions of a dollar. It's decimals of a dollar. And that's how it will be on your bill. And usually, actually, it's even 4 digits. It's something like, I should have brought in my bill, 1627. They have these crazy formulas that are the base price of per kilowatt hour. And they call it dollars, but Jerry was good to know that if you're looking at 0.14 of a dollar, that's 14 cents. So 14 cents per kilowatt hour. Now, kilowatt, you probably have heard of a light bulb, yes?
Yeah.
What's the usual wattage on a light bulb?
27.
Okay, so 27 watts, maybe 60 watts, maybe 45 watts. It depends on what the thing is, what the wattage is, okay? But this is kilowatt, so that's 1,000 times as big. 1,000 times. Kilo is metric, it's 1,000 times as big as some of these things we're talking about. But if you think of your whole house, how many light bulbs do you have?
68.
One?
No, I was kidding. I was like, the way she was counting me, I was like, she was only saying one.
Yeah. This is one light bulb. You probably have some in the front, some in the back, a couple in each room. All right, so they add up. Then you probably have a fridge. How do you think the energy of a fridge compares to a light bulb?
Takes up more.
A lot more. Okay, so kilowatt is way bigger than the watts you're thinking of, but it's a unit that's 1,000 times bigger than this big W for watts on a light bulb. And then per hour is, they don't charge you every minute. They look at a 24-hour clock and look at how much did you use total for the day. So they're charging you a price for a large amount of electricity used over an hour's worth of time. Yes?
So, like, if you work for PG&E, you get, like, discounts?
I have no idea. I don't work for PG&E. I get no discounts, okay? So here we go. Identify the independent and dependent quantities and their units in this problem situation. So, somebody's getting charged, right? What are they getting charged for?
Electricity.
Electricity used. And what are they getting charged in?
Money.
Cents or dollars. So we've got independent and dependent. Who's independent? Who's dependent?
It's a dependent the size of the bill.
Dependent is the size of the bill, so I'm going to say bill or cost, and it's being measured in dollars. And independent, what's the independent?
Time. Or how long it's been used.
How much electricity is been used? So, well, kilowatt hour incorporates time, but it's basically how much electricity you used in that time. So, electricity and kilowatt hour. Check your work. Some of you already have stuff written down. Is this how you have it? Because now that goes straight down to this table. Independent, we just said, was electricity. Measured in kilowatt hours. And dependent is the cost or your bill measured in dollars. All right? Write the expression and write the independent and dependent quantities and their units in the table. Then calculate total cost for each of the given kilowatt used. In the last row of the table, write an expression. So, if you don't use any electricity, what's it going to cost you?
Zero.
Oh, phew, that was an easy one. Now, if we're going to use, if we've used 1,000 kilowatt hours, how did you get that, Brody?
You just times it by 8,000.
Please excuse the interruption. May I please have Noodle sent to the front office?
He is absent.
Thank you.
You're welcome. Okay, we're going to times it. What's the it we're going to times? 1,000 times 0.14. 1,000 is the amount of electricity used. Is that getting too low? There we go. 1,000 is the amount of electricity used in that household that week, that month. And 0.14 was how much per kilowatt hour. So you do need to times them. What did you get when you multiplied?
140.
Excuse me? 140. Double check what you have right there. Okay? So now this one isn't as easy, but you have a calculator and it's the same thing. If this was, say you were buying shoes and you had a set price of $40 a pair, if you had one pair, it's 40 times 1. If you're buying 5 pairs, 40 times 5. Okay, who has probably the most shoes in here?
Me.
I'm gonna say lose.
You got a lot of shoes?
Yeah, I got like 6 pairs.
If he
I got more
has
than you,
6
bro.
pairs, 40 times 6, how many pairs?
18.
18 pairs. So he probably has a lot of sports shoes. And then he has some fancy
And
shoes.
the flip flops.
And flip-flops in school.
class.
How many do you have?
It depends on like shoes that I wear or shoes that I have.
Shoes that you have.
Like,
I have
like
20
probably like
pairs.
they're 10 pairs.
10 pair. Okay, but here's what I'm trying to say. This 0.14 is the set price, and then it's going to get multiplied up. So somebody who only has 2 pairs of shoes in their closet, you didn't pay as much money as he who had 10, or somebody who had 18. Who had 18? I forget. Jerry, who has 18. Now, you know that shoes probably cost different and his flip-flops don't cost the same as the sneakers, but we're simplifying things. So each step of the way you need to multiply. Jerry, what do you get as you move your way down this table?
168. Oh, 196.
I go 196.
224. 252.
280.
And then 280.
And then 14.
Okay, so this is going to be your electric bill if your house used this month, if your house used that this month, if your house used that this month, and none of those months yet look like when you put the Christmas lights up. Oh man, I love those Christmas lights, but they rack up the bill. Okay, a lot of electricity for me during the holidays. Okay, we have an expression we need to write. If you have X, what are we doing to any independent quantity to get the grand total? Multiply. So X times 0.14. Doesn't matter who's in front. If you have 0.14X, that's okay as well. Multiplying, it doesn't matter who's in front, who's in back. All right? So that was page 1. Calculate the rate of change between 3 different points. What do you notice? Now, rate of change is, we did a lot of different ways last week. Ah, man.
Miss Rigetti,
Yes. Can I help you?
did you send Noodle up?
Noodle is absent. You're welcome.
She was so like focused on the right things.
I said absent, didn't I say
Yeah,
absent?
you did.
Okay. All right, so calculate the rate of change between 3 different points. All right, so let's see if I can have my graph right here. You had a whole bunch of this kind of problem in the last packet. What you're looking at is how does these two compare and these two compare. And usually in rate of change, you're going to put the y's on top and the x's on bottom. And usually that would be independent quantity is x and dependent quantity is y. By convention, mathematically, we'll usually put x in the first column to make it easier for you to identify, and y in the second column. So for example here, I can go 140 minus 0 over 1,000 minus 0. Again, they want us to compare the difference between 2 spots on that table. Actually 3, don't they want 3? Okay, so I'm going to do that. Maybe I'll come down here and I'll do this one compared to that and this one compared to that. For the rate of change, we're not just looking at one variable. We're looking at how do both of them change together because they're both changing at the same time. 196 minus 168 over, let's see, what do we have? 1400 minus 1200. Again, you've been working these tables as a way to look at rate of change. I got to pick 2 more. I'm going to go all the way to the bottom and compare that one and that one. And this one and this one. So let's see. 280 minus 252 over 2,000 minus 1800. Always you're looking at y2 subtracting y1 and x2 subtracting x1. So this rate of change we are looking at different ways, and here's how it looks in this table. So if I go ahead with my calculator and do subtract and divide, I'm going to subtract both first. This one's easy. And then I'll do a divide to get it down to a decimal. And this one's going to be 0.14. Now I'm going to get calculator and subtract the top on clear 196 minus 168. That's 28. Are you all right?
Yeah.
Okay. And now I'm going to subtract the bottom 1400 minus 1200. And I get 200. So again, I set it up based on comparing two spots on the table. I'm putting the dependent quantity on top, and then I subtract. Now I divide 28 divided by 200. Uh-oh, what do I see? A pattern, 0.14. You guys right now with your calculators do the left piece. I want to see what's on top, what's on bottom, and how does that divide, please. We can kind of guess it's going to come out 0.14, but verify, please.